In this demonstration, we will define task types for Camundanzia's hiring process. This process starts when Camundanzia receives an application. This will trigger the start event. The first task in the process is calculating the transcript score for the candidate, based on the data about their competencies and skills. This should result in a competency level score described in a percentage. As this is a simple calculation, it can easily be done in a script. Therefore, we will define this task as a script task. In the next task, we want to save the application in the HR system. This system is a Camundanzia software with their own implementation and a very good API. Because this system is not part of Camunda, we need to implement a connection between Camunda and Camundanzia's HR system. This is typically done with a job worker. This means we need to define this task as a service task. The job worker can then automatically pick up the task and connect to the HR system. In the next step, after saving the information in the system, we need to check some basic criteria to determine if the candidate is a good fit for the role. We will start with the score we calculated in the first task and then add any other important criteria, such as, for example, if they have enough experience for the role or if they have the legal age to be hired, etc. This means we want to evaluate different criteria, and based on this, we will make a decision whether we proceed or not further with the applicant. This is done via a decision table, modeled with DMN. So we will define this task as a business rule task. As you can see, now you can link this task to a DMN table by clicking on the link icon that appears. After this is done, we can have two outcomes. A positive one, where the candidate is a good fit and move to the job interview, or a negative one, where the candidate is not a good fit and we send a rejection email. Let's start defining the tasks for the positive outcome. First, we have the interview by talking to the applicant. As this is not something the engine can do, we will set this task as manual. We are not choosing a user task here because even though a person will do this, at this time they will not interact with the system in any way. In the next step, the user will need to enter the result of the interview in the system. This is where we need to stop the process and allow them to complete the task. Therefore, we will define this task as a user task. Next, we have an exclusive gateway to evaluate the result of the interview. If the candidate is fit for the role, we want to send them an email automatically just to confirm we will proceed further. At this point, you can decide if you want to use a service task or a send task. Both task types allow you to implement a job worker that handles the sending of the email. Typically, in this case, you would use a send task to make it clearer and more visible in the model that you are sending a message. You also have the possibility of using our out-of-the-box SendGrid connector. The SendGrid connector is a pre-configured service task that enables you to send emails via SendGrid without any further implementation. To sum up, for this task you have two options. You can implement a job worker and choose between a send task or a service task. Or use the out-of-the-box SendGrid connector, which is a pre-configured service task. Then, finally, we want to update the data in the HR system. This means we need to communicate again with a system that is external to Camunda. So we will define this task as a service task as well. We now reach the end of the process for the positive outcome. The applicant is hired. Let's now go back to the second possible outcome for the applicant. If they are not fit for the role, we want to send them an automatic rejection email. So we will define this task as a service task. We want to update the data in the system in case of a rejection as well. So we define the last task as a service task, and the process ends with the applicant being rejected. Now all the tasks are defined. We will now use the token simulation to make sure the process is behaving as we expect. We should not have any interaction on the tasks that are automated, such as the service task, the script task, business rule task. As they should be automatically completed, the token will continue in the process. The manual task will also be passed through because it has nothing to do with the engine. The token should first stop and wait at the user task. Once the user completes the task, the token will then continue until the end of the process. To test our process, we first toggle on the token simulation. Then we click on the play button next to the start event. We can see the token moving through the automated tasks and stopping at the user task. Let's imagine the user completes this task and click on the play button next to it to see the process continue. As you can see, the token now indicates the process is finished. You now know how to define all tasks in a process and also test it to make it sure it works as expected. This concludes our demonstration.